Good day. Today I am going to make up the presentation for graph number 3 about our project for installations. First of all, I'm going to explain up the background of our project and make it up for all the spaces in our building and the regulations that we have to consider for the design. First of all, we got the first floor, which considers multiple rooms as the kitchen, the dining room, the main hall, the workshop, the garage, and bathroom and laundry room. Aside of that, we got the pump room and the outside of the building, which considers both backyard and the front yard. After that, we got the second floor, which only considers two bathrooms, three bedrooms, and a dressing room, aside of a terrace and a hallway. And lastly, we got the regulations for our building, which considers the materials, the enclosure, the register of construction among the plans, among other things, of course. For the materials, we got the Article 42, which talks about the materials of constructions admissible in urban spaces. For example, we got the concrete, we got wood, and other materials that can only be used on the central part of Guayaquil. Of course, our building considers only concrete. Next of all, we got the enclosure, the Article 49, which refers that in each subzone in Guayaquil it is necessary an enclosure. For example, we have the central part of Guayaquil, which obviously will need an enclosure. And lastly, we got the register of construction. On the article for 55, the construction registry is the municipal administrative authorization, which requires among some documents for the construction of our building. Detailing up the number of floors, the plans itself that we have to consider, among other things. And lastly, we got the plans that, well, just are designing considerations about how to present them.
Hello, I am talking about domestic water supply. To begin, we must define the distribution. On the slide, we can see the distribution of the drinking water supply system on the first floor of our project. The blue lines represent the cold water system and the red lines correspond to the hot water system. The cold water system is powered by a pump, while the system hot water is powered by a gas heater located next to the pump. On the fifth floor, the cool water system provides water to the dishwasher, washing machine, dryer, and bathroom. Instead, the hot water supply only provides water to the dishwasher. On the second floor, cold water is supplied to all of the fixtures in the two bathrooms. However, only the washers have a hot water supply. It's also important to notate that the montante is located in the upper right corner. Now I will talk about the design criteria. In the table, you can see the minimum flow and pressure used in all features of the project. For example, toilet with tank of bathroom 1 require minimum flow of 0.1 liter per second and pressure of 7 meters of water column. And kitchen sink require 0.2 liters per second and 5 meters of water column. These values are defined in Ecuadorian regulation. With this requirement, we begin the calculation for the sizing of the pipes. We used the critical row for the pressure. You can see in the table in a summary of the pressure carried out. We took our critical route from the shower in bathroom 2 on the second floor to the pump. The result was the minimum pressure of the pond is 24 meters of water column and half inches pipe for the entire system. With the required flow and pressure, we were able to determine the pond necessary for design. According to the diagram, the pond required is all red and 610 4. Into the technical specification, we have that the installation will be carried out by a plumber under the supervision of the technical manager. The pipe must be made of PVC, plastigama, capable of resisting pressure of 1 megapascal. And the measure will be carried out in linear meter with 2 decimal places, and pipe will be made by applying the unit price stipulated in the contract to the linear meter worked. As a final part of this section, we had to estimate the cost of our design. In the table, you can see the items into which the entire water supply system was separated. For this, it was necessary to carry out a unit price analysis APU and multiply by the number of units of our design. Data like rendimiento and hourly salary necessary for the APUs were obtained from Cámara de la Construcción de Guayaquil. It's necessary to clarify that the unit prices and quantity of item 1 and 2 are not per linear meter, but rather per each 6 meter pipe. Finally, the estimated cost of the domestic water supply is $1,247.
Hi, my name is Grace, and today I will be talking about sanitary drainage system. The drainage systems require the location of downspouts, which will be located along of the multiple fixtures that need discharge water. In the next figures, we can observe the distribution for the sanitary drainage system for this project. On the first floor, the 3 downspouts are serving, but in the second floor, we only have 2 downspouts in each bathroom respectively. Well, the WC was considered the critical fixtures in this project because it requires a minimum diameter of 4 inches, and the flow was also identified through the total units. The branches will serve as the main connection of all the water that the drainage, which have a level of slope the 0.4%, since all these systems work the gravity and requires a minimum level of velocity and height to work properly as shown in the table. For ventilation in this project, we choose the air extractor because are common option for bathroom ventilations and they adapt a aesthetic of the bathroom. For technical specifications, this pipeline should be located under the systems which distribute water to the building as a statement name, which each deposit or chair box should be separated from each other a minimum of 10 meters, and this deposit shouldn't be made any material that absorbs water and should be able for periodic cleaning and not accumulate many contaminants. The cost estimate depending on the design and pricing of the material to be used. The estimated price for the assembly of this system will be $1,130 in total. The stormwater drainage system will be provide a proper roof for the stormwater as is shown in the figure. Each zone have their slope to make the water follow it. In the layout, it's considered necessary to have 3 downspouts and distribute them in 4 areas. We defined the areas in rainfall intensity in 100, and using the rational method to the flow was calculated, and then using a table, the diameter of 3 inches for downspout was defined. For horizontal collectors, we use many tables were used and a slope of the 2% was considered. Technical specifications. Okay, these pipelines require a certain level of slope for water properly be discharged and shouldn't be made of any material that absorbs water and should be able for periodic cleaning and not accumulate that many trash and tree leaves. Cost estimate. Depending on the design and pricing of the material to be used, the estimated price for the assembly of this system will be in $376.32.
Now I'm going to explain the electrical system for the project we have. First of all, we got the electrical demand, which refers to the number of lights and number of current that we have on our building. For example, we have 16 lights and 14 conduits for our building. All of these distribute among them. For example, for lighting we got the entrance and main hall. For conduits we got just the main hall. We got no conduits and bathrooms but lights, and among all of these we got their descriptions. Points referring to the amount of lights and conduits that we have on each area. Um, the phase that refers to where in the breakers goes lights and conduits, the number of poles, the amps, the voltage, and referring to the voltage, we got to the list four special connections referring to air conditioner, the heater on the pump room, the laundry machine, and the wash machine. For our distribution, we got the first floor. Uh, that we explained before on the background that we got the workshop, which have at least 3 lights and 2 currents. Other than that, we got the rest of the building referring to the first floor. We got the garage, we got the laundry room, the pump room, the kitchen, among other parts of the house. And next we have the second floor, which like the first floor we got nothing that's very special among the connections that are for the special ones, the air conditioner, for example, on the main bedroom. Now we have the single light diagram, which starts with a transformer of single phase. Then we go to the socket, and then the connection to the main panel of the house. All of the systems that we got to see have their respective wires, the type of the pipe, their respective diameter, and of course we got the connection to the ground, which is of a copper wheeled rod. Now we have the technical specifications that refers to the specifications for wires, distribution panels, switch and outlets, and transformers, among other parts that refers to the electrical system. For example, the switches and outlets represent the use of lights and other electrical installations that require a certain type of voltage. Differentiates, for example, the outlets that requires 120 voltage and 240 voltage. Other than that, we got the distribution panels that need to be a certain height, and we got the transformer that should be of a single phase, three phase, etc., that need to give enough power to the building. And lastly, for the electrical system, we got the cost estimate. That, as we can see, we got multiple prices for certain type of items. Most of the cost that comes from the panel, and other than that, we got at least two different marks for for buying, like Mega Kiwi and Ferry Maxi. Other than that, we got a certain variety for for the wires and the boxes of PVC, the connectors, and of course the breakers. All of these prices sum a total of $860. That for the price for the installation for the electrical installations, it is pretty good.
Well, analysis of alternative. Evaluate sustainable alternative for electrical design, such as including the installation of low consumption LED lighting systems to obtain cost reduction and contributions to environmental sustainability. Well, apply automations technology for the efficient control of electrical installations and water management. This could include home automations system for automatic regulation of lights, temperature, and irrigation systems. And finally, analyze various materials options to determine the most cost-effective combinations without compromising quality and efficiency. Considering supplier and contract options that can reduce costs without sacrificing the integrity of facilities. Recommendations and conclusions. Well, it's recommended to delve into the performance of activity to refine the budget estimated, since the cost of the project was carried out with resources extracted from other works. In this could vary the final budget. In conclusion, my persons and my friends consider the project covered all the details that, as designers, must be considered the optimized costs and times in the execution of a work of this size. Thanks.